Hello everyone, let's solve some LeetCode today. So we are going to start with this two-sum problem. It's a very famous problem, and to be honest, there are a couple of ways to solve it. Basically, let's just go through the description first of all. So given an array of integers, nums, okay. So we basically have an array of integers like this. There is a target that we need to follow. Okay, so we have to return indices. That means index of two integers, I believe, that they add up to the target. So basically, we will have a target or a target number, and we will have an array of integers, and we will have to figure out the two numbers, okay, the two numbers that will add up to that target. So for example, 7 plus 2 equals 9. Okay. So these are the two numbers that actually add up to the target 9. And so we have to return indices of the two numbers. So we are not supposed to return the two numbers. We are supposed to return the index of two numbers. Okay. So the index of 2 is 0 and the index of 7 is 1. So we have to return 0 and 1. This is the problem that we have. And okay, so there is also a condition called exactly one solution. So they are actually saying that we have exactly one solution. So there will be no test case where there will be no two numbers that does not add up to the target, which means we will always have a valid input array. Okay, so there will always be single solution. There will be no multiple solution or zero solutions in the array. We cannot use the same element twice. Okay, so we cannot use the 2 twice. Okay, if the target value is 4 and we say that okay, we have 2 at 0 index, and then we can also use 2 at 0 index again, so we cannot return 0 comma 0. Okay, so that is one condition, that we cannot use the same element twice. Like this, try to understand how this problem can be solved. So we will have an array, okay, and the array will be like 2, 7, 11, 15. Okay, and then we have a target t of 9. Now we have to figure out which two elements actually add up to the 9. So we know by observation here that 2 plus 7 equals 9, and we have already told in the question that there can only be one solution. So we will simply return the indexes of 2 and 9, okay, and this will be answer. It will be our answer. So one solution or one brute force solution for this thing is to take 2 and then compare it with every other element. Then take 7 and then compare it with every other element. Then take 11 and then compare it with every other element in the array. Okay. So we can use this to actually figure out, which two pairs of the two numbers actually add up to the 9. This is definitely a brute force solution. Complexity or the time complexity will be order of n square, where n is the number of elements in the array. So this is definitely not a good solution, but it's a brute force solution that you can tell to the interviewer while you are presenting number of solutions. But as you can see, this is a brute force solution, and most likely you will be asked to actually give some optimized solution for this. And one of the solutions for this is using a hash map. Okay, so first of all, let me just tell you the intuition. So we have 2, 7, 11 and 15, and we have a target number 9. Okay, so suppose that we are on the 2. So let me just write it again: 2, 7, 11 and 15. This is the array. Okay, we have our target 9. So suppose that we are on 2, we have the 2 element, and now we have to figure out whether there exists another number that we can add to 2 that will end up giving a result of 9. So what it means is we need to figure out x. 2 plus x equals to 9. So we can say that x is equals to 9 minus 2. 9 minus 2 is equals to 7. Right? So basically what we have to figure out is, does there exist a number, okay, that is equals to this x. So, and we can do the same for 7 also. Okay, so if we have 7, now we just have to figure out whether 7 sorry 9 minus 7 exists or not. If this number exists, 9 minus 7 or 9 minus 11, or these kind of numbers exist, we can say that yes, the array contains two numbers that basically add up to the 9, and then we can return their indexes. Okay, so how do we do this? Well, first of all, we have to store the number and their indices, right? So what we can do is we can use a hash map. Okay, hash map or a dictionary if you are from C# background. So suppose we have this value here, and then we have index. Okay, so we have these two things, so we can write a 2, 7, 11, and then 15, and then their indexes is 0, 1, 2, and 3. So we have this value stored, right? Now we come to 2. Okay, in the code we have the value 2. Now we just have to check in the hash map, does 9 minus 2, this number exist or not. So 9 minus 2 is 7. Okay, it exists here in the hash map. Oh, that's a wrong arrow. This exists here in the hash map. So we can say that yes, we have an exact solution, and then we can just get the access of these two values, 0 and 1, simply by using the dictionary, and then return it 0 comma 1. Okay, but here is a catch. Okay, here is a catch. Let me remove all of it. So we are supposed to basically give a target, right? Not target, we are supposed to find this 9 minus 2, or target minus number, right? Suppose that the target is 4. Okay, and we are on 2, we have the value 2, we have to figure out, we had there is another number that we can add to 2 that will sum up to 4. So if I try to find 4 minus 2, okay, then we can see that yes, the dictionary will tell us that it exists. Okay, right here we have 2 right here, but it's not correct, right? Because we are basically using the same element twice, and in the condition we can already see that we cannot use the same element twice. We cannot use the same element twice, so this is a wrong solution, correct? But if we actually prepare the array, or not the array, the hash map first, okay, in a single pass we prepare the hash map first, and then we try to find this number, then we are going to like get wrong result, because it will actually try to take the same number twice. So how do we solve it, right? And one way to solve it is to basically just don't store everything in the hash map in the starting. Okay, you store it as you go. So for example, we are going to do it in a single loop. This means we are going to do it in a single pass. Okay, so let me just write another hash map. Okay, we have this hash map, we have val here, we have a index here. Okay, we have this array, and we have a target of 4. Suppose we have a target of 4. Okay, and yes, currently there is no solution for it. Let's just make it 9, because our question says that there is at least one solution, exactly one solution, not at least. So yeah, in our loop, in our for loop, okay, we first went to 2. We first have the value of 2. Now we check, does 9 minus 2 exist, right? Does 9 minus 2 exist in this array? And we can see that this hash map is currently empty. So it will say no, 9 minus 2 does not exist in the hash map. It does exist in the array, but currently it does not exist in the hash map. So what we will do is we will go to the second number, and we will add this 2 into the hash map with the index. Okay, now we go to the next number. Let me just remove this stuff. Okay, this stuff needs to be removed. And yeah, let's go to the next number, that is 7. We are now on 7 here. So this is 7. Now we need to figure out, does 9 minus 7 exist? And it does, right? So we have this 2. 9 minus 7 is equals to 2. So we do have this number here, and it does exist. So we can say that yes, this 9 minus 7 exists, and the index of that is 0, right? So the index of 2 is 0, and we already have the index of 7. We got the index of 2 from the hash map, and we got the index of 7 from our loop. Okay, so we can say that we can basically return 0 comma 1, because we have both the indexes. And as you can see that we do not have to fill out the entire hash map, or go through the entire loop. The second we found the answer, we just returned the answer, simple as that. Because like if I have two numbers, okay, 2 and 7, so 9 minus 2 is equals to 7, and 9 minus 7 is equals to 2. Okay, it doesn't matter which one we find first. Okay, which one we find first, it doesn't matter, because as long as the other part of the equation exists, as long as the other number exists, it's fine. We can just simply return the result. Now there is one more solution actually, but that solution is very specific. Okay, let me just code this one first. Okay, I have already coded this solution here, because when I was working on this, I already coded this solution. What we are doing here is we are creating a dictionary, not a dictionary, an array of size 2, because this will be a result array. We are going to send back the indices of the two numbers, right? So it's just a result array. We are going to send the indices. Then we actually create a dictionary for integer and integer. So for every value, we are going to store its index. Okay, and then we are basically running a for loop from 0 to nums dot length, so the length of the integer. And we are checking at every loop that does the dictionary, this dictionary contains the target minus whatever number we are on, nums of I, whatever number we are currently on, nums of I. So we are checking it. Okay, if it contains, okay, then what we are doing is we are basically making our result. Okay, I, that is our current index, and then diction and the index of the number that exists in the dictionary. Okay, dictionary target minus nums I, we are basically creating an array of that, and then we are basically sorting it. You don't have to sort it, you can return answer in any order, but I just sorted it for simplicity's sake, and then I returned it. Simple as that. Return the result. Okay. Otherwise, what I do is I basically add whatever current number I'm on currently. That is maybe I'm on 2. So I add 2, and then the index of this integer. So the index of 2 is 0. So I add 2 comma 0 in the dictionary. Okay. Otherwise, if the entire loop runs away and we don't find any answer, we simply return an empty array, because there is no answer. There is no answer in case there is no input integers. Okay, because we have been told that there is exactly one solution, which means if there is no answer, that means the input array was empty. There was no, basically there was no element in that. So this is basically how you can write your code. And yes, this res is kind of useless at this point, because I used this thing. So you can actually remove this thing, this variable, and it will still work. But there is one more thing that I would like to show you here. So there is one more solution that can actually work in a particular situation, and that particular situation is when the array is equals to sorted. Okay, if your array is sorted, then this particular solution can work. The above solution, this hash map solution, will work whether your array is sorted or not. That doesn't matter. So that is why the hash map is basically a more accepted solution. It's a more general solution, because in our question, it's never written. It's nowhere written that our array is sorted or unsorted. As you can see, this array is sorted. Okay, but this array is not sorted. 3 2 4. It's not sorted, right? That's why this dictionary solution is basically what's going to work for this question. But if it's told that the array is sorted, then you can use actually something called two pointer approach. Because right now in our current solution, okay, in our current solution, the time complexity is, yes, order of n, because we are only passing through the loop once. Okay, we are only going to each and every value in the array once. So we can say that yes, the loop basically runs one time or goes through the n numbers. So we can say yes, this time complexity is order of n. But the space complexity, okay, the amount of space you are taking, extra space, is also order of n. Okay, because you actually might need to create the complete hash map from the array, because you don't know where the two numbers are. In case of, in worst case situation, the two numbers might be at the extreme ends of the array, one at the starting, one at the end. So you will end up creating the entire hash map from the array. So in the worst case scenario, this can be the time complexity and space complexity. But if it's told that the array is sorted, then this space complexity can be constant. So space can be O of 1. And how? We can do this with the help of two pointer approach. So suppose that we have this array 1, 2, 3, 4. Okay, we have this sorted array, and the target is 6. Well, we can't have a 6, right? Oh, yes, we can have 4 plus 2 is 6. Okay, So basically we can see that 4 and 2 are basically the answer of this question. But how are we going to do this without using HashMap, right? What we can do is we can place one pointer or one variable here, and we can place another variable here. Okay, so we have one pointer A pointing to index 0, and we have one pointer B pointing to index n minus 1. Okay, now we add these two. We can say ARR, or array of A plus array of B. Okay, basically we add these two values 1 and 4. We see that 1 plus 4 is 5, right? 1 plus 4 equals 5. Now 5 is what? 5 is less than 6. 5 is less than 6, which means I need to increase A. Okay, I need to push A towards the left so that I can make this number, this sum, bigger. Okay, and I can hope that, if I make this sum bigger, I might actually reach 6, okay. So I increase the A to 1. So now the new value of A is index 1, and B remains the same, n minus 1. Okay, the end. Now ARR A plus ARR B is equals to 2 plus 4 is equals to 6. Okay, which means our target is finally found. So this is how we can actually use two pointer approach to solve the question for sorted array. And in case, right now it was basically less than 6, right? If this was number 7 and greater than 6, what we can do is we can basically reduce the B, because now we know that we need a smaller sum. So we reduce the B to here, and we can try with a smaller value. So as you can see, based on the sum of this thing, ARR A plus ARR B, we are going to reduce B or increase A. Okay, and we can hope that we will find the answer, or there will be two numbers that will sum up to the 6. Of course, if at any point, B is less than A, B is less than A means the index B is less than A, not the value. So right now the right now A is 0 and B is 1, 0, 1, 2, 3. Okay, so the value of B is 3. Okay, in case if I reduce it by 1, B will become at the index of 2. Okay, A, if I increase it, it will come here 1. If I increase it one more time, decrease it one more time, and increase it one more time, we will have A at 2 and B at 1. So B, if B is less than A, we can say that there is no solution exists, because we have already gone through all the numbers in the array. So we can return an empty array. Simple as that.